Recording? There's no red dot. I'm Anthony Bound, here in the lab with James Brown. Harsh is a little sick, couldn't be here with us. But we are about to test two sensors on our robot simultaneously. Now this thing is still running from battery power. We're looking to do power implementation after we make sure all the sensors can work. Because we don't really want to crack this thing open until we're ready. What's going on here is we're going to be testing its light sensing ability by use of this little photoresistor here. It changes resistance based on light shining upon it. I believe in darkness it spikes in resistivity, and in the light it lowers. By putting this resistor in series with this one right here, this 1K, in the middle, we are using the property of the voltage division by taking a measurement in the middle of the two resistors where they meet, right here. Then we're sending that over to our analog detect sensor over here. And it's going to give different readings for the amount of voltage. The computer will then interpret it as levels of light. We've got it set to run when it's in the light, as is part of our test, and to turn 90 degrees when it hits a wall. Now, how's it going to detect that? I'm glad nobody asked. This right here is a wall sensor. It's a spring wrapped around a pin. The spring runs down this wire to the end where we can bend it. Or it bends whenever it hits an obstacle. See the wire? When the spring bends, it will touch the pin, completing a connection. I've drawn a brief diagram of how it's set up right here. Thank you, James. This is the contact where the spring would meet the pin. It's connected to ground. Otherwise, the sensor goes to 5 volts with a small shunt resistor, just to make sure it doesn't. It's a small guard resistor, just to make sure it doesn't fry anything, or send 5 volts straight to ground. When the spring hits a wall, it's going to complete the connection, sending this ground straight to the sensor, and the sensor is set to fire on ground.